I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. PGFPLOTS enables easy plotting of data inside LaTeX documents. Today I'll talk about working with data files in PGFPLOTS. I'll show the basics of how PGFPLOTS expects the data file to be formatted. I'll show how to read the data file only once and reuse it over and over again. I'll show how to specify that your data file is comma separated rather than PGFPLOTS' default assumption of space separated. I'll describe how to work with data that doesn't have headers. I'll explain how to represent missing values. Finally, I'll show how to declare a file right in line inside your LaTeX document. These videos are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. Today, I'm going to show you about working with data files. For this reason, my setup today is a little more complicated so that I can show you the data files and resulting tables in various ways. To start off with, I'm using a special geometry so that things are clear on screen. I don't recommend this geometry for any typical project. Here I'm setting the paper width to 9 centimeters, the paper height to 85 centimeters, and the margin to just 5 millimeters. I'm using parskip to make things look nice, and I'm using hyperref to link the author name back to the YouTube channel. Now we come to the complicated parts. I'm using the listings package to display text files. I set the options up here with LST set. I'm telling it to frame the file, render it in teletype font, and put file contents along with the file name as the title. Next is PGFPLOTS, which we are already familiar with. We'll be using the same data over and over again in different formats, so I'm setting everything up front. The scale only axis is covered in the Getting Started episode. I'm setting the size to 6 by 4 centimeters. I'm setting the legend up front and also setting the X-tick distance up front, just because that saves me some typing later on. Lastly, I'm using something called PGFPLOTS table. This is going to be required for reading our data files once and reusing them. I'm going to also use this for displaying what we've read in as a table. So I'm setting up this PGFPLOTS table set, and I'm using some settings that will be useful when you do want to debug your tables. This is setting some lines before and after the top line, making the top line in bold, and then putting a line at the bottom of the table. And then I'm treating every entry in my data as string type. And again, that's just useful for debugging purposes. Before we get into all the complicated stuff, I'm going to show the basic file setup and usage in a PGFPLOTS. I've already uploaded the data files we'll use today to Overleaf. In the code I'm pasting here, the LST input listing command displays the file data.txt. Let me compile this so you can see what it looks like. By default, PGFPLOTS expects column headers on the first line, and then the separators are any number of spaces, and then new lines are the row separators. This file has 3 columns labeled ID, A, and B, and it has 4 rows of data. The plot is using the first column as the X values. This is the default, and it doesn't need to be specified. Then the 2 plot commands use the A and B columns, respectively, as the Y values. The way that the add plot command in the example we just did works is that each one opens and rereads the data file. So we read it in once here, and then we read it again here. This is generally fine for small data files, but it can become expensive for larger data files. The PGFPLOTS table package provides a command to read a data table in and save it for usage over and over again. Here's what that command looks like. So here I have PGFPLOTS table read as one very long word, the name of the data file, and then the name of the macro in which to store it. So I'm reading here the file data.txt, and I'm storing it in the macro /data table. For debugging purposes, it can be useful to display the table. So another thing that we can use from PGFPLOTS table is this command PGFPLOTS table typeset, and then the macro that's storing our table. When I compile this, we get a table below. Recall that I set a bunch of defaults above to control the display of my tables using PGFPLOTS table set. Finally, we can use this data table in a plot. So here I'm creating something that looks very much like we had before. It's identical except that I have taken data.text and replaced it with data table. When I compile that, we get an identical graphic to what we had above. The next question you might ask is, what do I do if my data is comma separated rather than space separated? One option is to write a quick program to swap the commas for spaces, being careful that you enclose any multi-word entries in curly braces. Another option is to specify that the column separator is a comma when you read in the table. So let me show you a different data file that's comma separated and how to read it. So here's a bunch of stuff. I'm going to compile that. So we have our data file. Instead of data.text, it's data.csv. And so here's its contents. They're the same as before, only we're using commas instead of spaces. In order to read that data file using PGFPLOTS table read, the only difference here is I'm saying that the column separator is a comma. That's COL space SEP. I then plot the data as usual, and we get the same graphic that we had before. I'll also note that here I am reusing the same macro name for the data table as above. So this overwrites whatever I had before, and it's fine to reuse the macro name as many times as you wish. And just after you've reused it, you won't be able to access the old data. You only have access to the new data. Another common issue that you might run into is data files that don't have headers. Again, you could go in and add headers, but there's also ways to deal with it directly within PGFPLOTS. So here's an example of a data file that doesn't have headers, it just has the data. So how can I use that? We can read the file as normal. I don't need any special options because it's already space separated. And so I'm just going to read in this file data no headers.txt into the data table. And then I'm going to look at what I've read in using the PGFPLOTS table typeset. So this is interesting because I have 0, 1, 2, where the column headers would normally be if I had them. This case is a little bit different way that you reference the columns using the addplot command. You're going to instead use something called y-index. So I'm going to go ahead and paste here and compile it. It's going to give us the same thing as before. And what's really different is instead of y equals A and y equals B, I'm saying y-index equals 1 and y-index equals 2 for the two different plots. And that's because the indexing starts with 0, and so I can always just say which column I want to use by number rather than by title. And you can do this even if you already have column headers. You can always index by y-index. If you have some missing entries in your data, that's actually okay. My recommendation is to have an NaN whenever data is missing. So here I'm showing an example where column A has no entry in the row corresponding to ID equals 3. So let me compile that and show you what I mean. So here, this is a missing entry. An option for a missing entry is to simply leave it blank. This works fine when your data is comma delineated. It does not work at all when your data is space delineated. Then you need to use curly braces and it gets more complicated. But if you just use NaN, you don't have to worry about that. So we read the data as usual for a comma separated file. So we just indicate that we want the column separator to be a comma and everything else is fine. In the graphic itself, I've plotted it the same way as usual, but you'll notice there's a data point missing here. And that's the missing data point. And it goes directly from plotting 2, 5 to 4, 2.2, and it's missing that point because it's not there in the data file. There is a message in the compilation log that says something like, note, coordinate 3, NaN has been dropped because it is unbounded in Y. See also unbounded coords equals jump. There's another way you can handle it if you want to do something differently, but I'm not going to cover that today. Last but not least, it's possible to create a data table right inside your LaTeX document. This is especially useful for very small bits of data that don't necessitate an entirely separate file. So here's an example of the same data file we've been using, declared Inline. You can use whatever row and column separators that you like. I could use the usual spaces and new lines. In this case, however, I'm using LaTeX-like table declaration with a double backslash as the row separator and an ampersand as the column separator. To check that everything is as expected, I print the data table after I read it. So let's see what happens when I do that. So here we get the data table that I've declared right here using PGFPLOTS table read. And instead of getting a data input, I literally just put the data of the file. This plot is the same as if I had read it from a file, and this is a really good option for when you have little teeny data files. I hope you enjoyed today's episode on working with data files in PGFPLOTS. I include a link to the overleaf document I created today in the show notes. If you found this helpful or interesting, please click like or subscribe. If you have TXC or PGFPLOTS questions, please post them in the comments. If you want to learn more, please check out the other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.